Good morning, guys. Welcome to today's lesson, April 22nd, Delta Math. As you can see, this lesson is all about, how do we get 100% on this week's Delta Math? Now, most of the topics are topics that we've had on Delta Math for months now, so those should be no problem. All the new topics, like all the distance learning topics, we're going to talk about, and mainly dealing with Module 5 and circles. We're going to have some questions throughout the lesson, like the section under arc measure. We have a couple of those. We'll take a look at that. The inscribed angle theorem, intersection of chords, secant tangent, area of a sector. Those are all topics on Delta Math. So those are new-ish. I want to make sure that we're totally good to go. You feel 100% confident. You walk away with this week's Delta Math with 100%. Not even a 70 or an 80 or 90, 100%. Eventually, your final for this class is going to be on Delta Math, so I just really want to make sure you're comfortable with all the topics. Alright, so you're due now. Which equation represents a line which is parallel to the line y equals negative 3/4 x plus 6? And you see your answer choices there. Now, there is an algebraic way, but honestly, you see your aim today. How do we get 100%? The easiest way is to graph it in GeoGebra. So let's graph our initial line. And now it's also good to notice, guys, they said parallel to this equation. They didn't say it has to pass through any specific point. It literally just has to be one of them that is parallel. All right, now let's go through our choices. The first one, 3y minus 4x equals 15. All right, you can kind of see in the screen there. We're going to zoom in on GeoGebra in a second. But that would not be parallel to the initial line. Alright. Wouldn't be that one either. Let's go through. 4x plus 3y equals negative 18. Check real quick. That green, nope, the green and the orange, they do intersect. So, should be choice 4. Let's check it. 3x plus 4y equals 32. Alright, you can see that they are parallel, the green and the purple. Now the way you could check that, you can make sure that they have the same slope. Alright, if you count the boxes, what's the change up and down, left and right, all that. Alright, it would actually be, if I'm picking 2 points that hit the corner of a box, which for right now, let's say it was that point and that point, it would be down 1, 2, 3, right 1, 2, 3, 4. So negative 3/4. And that would be the exact same slope for the purple line. Down 3, right 4, negative 3/4. Alright. Now the next one. Same type of question. Let's fill in our answer choice here. Which equation represents a line which is perpendicular to the line y equals negative 3x minus 5? Alright, so that was parallel. Now we're looking perpendicular. So what do we know about perpendicular lines? About their slopes, more specifically. They're opposite reciprocals. So right now, your slope of the initial line, because this is in slope-intercept form, you can see the slope is negative 3. We need the slope that is perpendicular, which means we have to flip it, so it would be 1 over 3, and change the sign. So we go from negative to positive. Alright, so we're looking for a line that has a slope of 1/3. Let's clear all this out. So your initial line, y equals negative 3x minus 5. See your initial line. Let's go through with our choices. Choice 1, y minus 3x equals 3. not quite perpendicular. Below that, 3x plus y equals 5. Once again, close but not quite perpendicular. Next one. Not quite. And finally, x minus 3y equals negative 6. So you see the gray line and the orange line, those are indeed perpendicular. Once again, let's just check for that slope. Make sure that we have a slope of 1/3. Find 2 points that hit the corner of a box. So for example, there and there. And that is up 1, right 1, 2, 3. So a slope of 1/3, just to check it. But you can really tell. You can look at the graph and say, okay, that's parallel, that's perpendicular, whatever. But it's good to check it with the slopes. All right, but honestly, this is the easiest way. Put it into GeoGebra. You can see the graphs, all right, and you can tell which is parallel, which is perpendicular. So that's one topic on Delta Math you should knock out of the park. All right, we're going to go through all these. So now the section in Delta Math that says arc measure. Encircle K with the measure of angle JKL equal to 138 degrees. JKL, that angle is here. Find the measure of minor arc JL, which is that right there. All right. Now, this is a central angle. The central angle is equal to the intercepted arc, which is 138 degrees. Nothing too crazy. A central angle is exactly equal to the intercepted arc. Remember, the intercepted arc is the arc that the angle opens up and really hits. Now, a question down the road could ask you for this arc here. Alright, now that's the rest of the circle, so we could do 360 minus that to get 222. Now that's not part of the problem, just a side note. Alright, next. Encircle F, this is still in the arc measure section of Delta Math. Encircle F with the measure of minor arc EG, so equal to 122. Find the measure of angle EHG, which is here. Alright, so this is what type of angle? This is an inscribed angle because it meets the vertexes on the circle. That's equal to half of the intercepted arc. The intercepted arc right now is that 122 that they gave us, because you see how X, that angle opens up and hits that 122 degree arc. So you take that 122 and you cut it in half, you get 61. Still in the arc measure section, there's a couple different ways that they can ask this question. All pretty simple, but stay with me here. Encircle C with the measure of angle BED equal to 17 degrees, so angle BED, 17 degrees. Find the angle measure of minor arc BD, which is here. Once again, this opens up, the 17 degree angle opens up and hits that arc BD. All we need to do this time, we're going in reverse here. Now they gave us the angle and we're looking for the arc, so we have to double it. So this would be 34 degrees. In the last problem, we cut it in half because we were looking for the angle. This time we're looking for the arc, so we had to double it. Alright, moving on. So now we're in the inscribed angle theorem section of Delta Math. Encircle C with the measure of angle BED equal to 60. Find the measure of angle BCD. So this is where the central angle, which is X, and the inscribed angle, 60, they intercept the same arc. So you see how 60 opens up and hits arc BD, and X opens up and actually hits that exact same arc. So the intercepted arc in both cases is BD. Alright, so 60 degrees, that's an inscribed angle. To find that arc, you double it, just like we did in the last one, to get 120. And then the central angle now is equal to exactly that, no cutting in half or doubling or nothing like that. It's equal to exactly 120 degrees. So the central angle is equal to the intercepted arc. The inscribed angle is equal to half of the intercepted arc. Right, one more in the inscribed angle theorem section. Encircle R with the measure of angle QRS equal to 46 degrees, which is here, QRS. Find the measure of angle QTS, which is this little guy right there. Once again, these intercept the exact same arc. See how 46 opens up and hits arc QS. Same deal for X here. Watch how that opens up. That also intercepts arc QS. Alright, so we can find that arc, which will help us then find X. That arc would be equal to the central angle of 46. To find the inscribed angle, you have to cut that in half. Not a lot of room in there, but this angle would come to 23 degrees. 46 divided by 2. So angle QTS equals 23 degrees. Alright, now we're on to the intersection of chords section of Delta Math. This was similar to your do now, I believe, yesterday. We're dealing with segments now, pieces. Now we're not dealing with angles. So two chords intersect. The green one here and the blue one here. Take the two pieces of the green one, 10 and 7, set it equal to the two pieces multiplied by each other of the blue one. So the two pieces of the blue multiplied together, the two pieces of the green multiplied together, and set them equal to each other. So we get 70 is equal to 14x divided by 14. X equals 2. 70 divided by 14 is 5. Now this is the only way in Delta Math that they ask this question. Alright, so we're on to our next Delta Math section. So this is the secant tangent section. It's nice that they told you that. That's what we're dealing with. We have one line that's a tangent, which is x here, and then the other line, the other segment is a secant. Remember the rule for secant? I didn't really like how they asked that question in Delta Math, so I didn't include secant. That was OW equals OW. Alright, but when it's secant tangent, the rule is O squared, the outside times itself, is equal to the outside times the whole. So O squared equals OW. Right now, O squared, so the outside, that's of the tangent, times itself, so x times x is x squared. That's equal to the outside of the secant, which is 2, times the whole. Be careful here, it is not 30. We want the whole piece, which is 30 plus 2, which would be 32. So 2 times 32, and then you simplify. Alright, you get x squared is equal to 2 times 32, which is 64. And you have to square root to get that squared away. We get x is equal to 8. Alright, on to your next section of Delta Math. Remember, this is so you can get 100. This is the exact questions you'll see, just with different numbers. Another secant tangent, so same rule. O squared equals OW. So the outside times itself for the tangent, 12 squared, is equal to the outside, which is 3, times the whole, which is, Now, the whole piece right now, guys, is what we would have to solve for. We can't just find x, like in one shot right now. We can't just find x. our formula here would allow us to find the whole piece. So I just want us to mark this off here. We'll call that W, the whole thing. So we'll find the whole piece, and then we'll subtract 3, and then you'll find out what x is equal to. Alright, now you could call the whole segment x plus 3 if you wanted, but then you're involving more algebra than you really need to. Alright, right off the bat here, we're just going to find W. The whole, and then that'll enable us to find x. Alright, so 12 squared is 144, is equal to 3 times W. Divide by 3. And we get W, the whole piece, is equal to 48. Be careful, don't use 48 as your answer. That's 48. So x is equal to 48 minus 3, and you get 45. Now you can, I'm not saying don't, you can use the whole expression and say it's x plus 3. It's up to you. But remember, if you're thinking about it logically, I solve for the whole thing, and then I just take off the 3. That'll enable me to find x. All right, and then area of a sector we've been looking at for the last 2 days. This question is just not the way they ask it in Delta Math. They don't say leave it in terms of pi, that you actually multiply out with the pi. So let's see what they say here. Encircle P with the measure of angle NPQ equal to 42. And NP equal to 19, so the radius there. 19 units, find the area of sector NPQ, round to the nearest hundredth. So remember your formula. This is a formula you have to memorize. It's just the central angle over 360 times your regular circle formula for area, times pi r squared. So the area is equal to, they give you the central angle, 42 over 360 times pi times the radius squared. Now usually with the examples we look at, most times the regents will just say leave it in terms of pi. We would multiply that and that, and then leave the pi along at the end. However, this does not say that. It says to actually round to the nearest hundredth. So that's what we're going to do. The 132. Alright, so make sure you're rounding correctly, or else Delta Math will not give you credit. You'll have to do this all over again. Round to the nearest hundredths place, which is this place right here. That's the hundredths place. So let's take a look to the right of that. That 3 tells the 1 to stay put. If it was 5 or greater, it would tell the 1 to go up to a 2. But this would be 132.31 units squared. Alright, so that's the whole worksheet today, guys. You have nothing left to do for this worksheet. Just make sure you take good notes. And I want to make sure you get 100% on Delta Math. This is all, everything else is like your normal SOHCAHTOA stuff, your normal find the angle. Right, this is what's really new, what we've been looking at in the distance learning. Use GeoGebra as much as you'd like. Look at these circle problems. They're the exact same problems. Every single way they can ask it in Delta Math is accounted for in this worksheet, so use it. It's here to help you. All right, that Delta Math is due tomorrow at 8 o'clock. Let's get it done on time. Ask me questions and remind if you have them, and that's it. Have a wonderful rest of your day, and I'll see you mañana.